Welcome to the tutorial on simultaneous equations, and in this lesson we're going to quickly go over the practical example of how you would use simultaneous equations in everyday life using a practical example. So the practical example, let's say you have been asked to order a set of tickets to a Noel Gallagher show at the Edinburgh Playhouse for 10 people. Now a concession ticket costs £20 and a standard ticket costs £30. And you need to order 5 concessions and 5 standard tickets. So how would we go and solve this kind of problem to figure out what the total cost is? Well, if you know your linear algebra, this should be quite straightforward. The total cost would be 5 times C, which is a concession, plus 5 times S, which is the standard. And that comes to 5 times £20 plus 5 times £30, which is £100 plus £150. Add those together, you get the total cost of £250. And this is the equation that we have. We have 5C, 5 concession tickets plus 5S, 5 standard tickets, comes to £250. Simple, straightforward. But can we do this in reverse? So let's say David, he goes to the Edinburgh Playhouse ticket office and he orders 5 concessions and 5 standard tickets, and he is given a VAT receipt and it comes to £250. Now David has to go back to his friends that he's ordered for and get the money off these people individually. But he doesn't know how much an individual ticket costs, he only knows the total cost. So is there a method that we have which we can solve a single concession ticket and a single standard ticket price? Well, we have the equation again. We've got 5C, 5 concession tickets plus 5S, 5 standard tickets, comes to £250. Which is just taken directly from this. Well, we have 2 unknown variables. So we have C, a concession ticket, and S, a standard ticket. We need to figure out how much one of these costs on their own. But we only have one equation. So is it possible to do this? Well, say a concession ticket costs £15 and a standard ticket costs £35. That would give us the solution. Or perhaps we would have the concession ticket at £10 and the standard ticket would be £40. That would also give us the correct solution. How about a concession ticket was £1 and a standard ticket was £49? Again, that would also give us a correct solution. So, as you may be guessing at the moment, you can see that there are many possible solutions to this. Now, Kirsty, she's also going to get some tickets for this show. And she goes to the box office and she also gets a VAT receipt. Kirsty has ordered 8 concession tickets and 10 standard tickets, and the total costs comes to £460. And we have the equation there. 8C plus 10S is 460. So now we have 2 unknowns and 2 equations. We have first equation, 5C plus 5S is £250. And we have the second equation, 8C plus 10S is £460. So using David's equation and Kirsty's equation, we know that there exists one pair of C and S values that satisfies both equations simultaneously. So we have 2 unknowns and 2 equations. We can solve this. So what is the method that we use to solve? The easiest and probably the most common is what is known as the elimination and substitution method. So the first part of this is we need to match coefficients of one of the variables. What do I mean by matching coefficients? Well, looking at our equations again, a coefficient is the multiplier in front of the variable. So here 5c, 5 is the coefficient, 8c, 8 is the coefficient, 5s, 5 is coefficient, 10s, 10 is the coefficient. So what we want to do is we want to match the coefficients of one of these variables. So there's a number of ways we can do this. The first one, we could match the coefficients of the variable c by multiplying equation 2 by 5 and equation 1 by 8. And this will give us 8 times 5 is 40c, and down here we'll have 5 times 8 is also 40c. So we'd have 40c, so the coefficients are equal. Or, easier, we could divide the second equation by 2 to match the coefficient of s. So 10 divided by 2 would be 5, and we've already got 5 at the top here. So we both have 5s on each of these equations. That's just the same. We could do the top equation. We can multiply that by 2, and we'd have 10s and 10s right here. So let's go ahead and do that. We'll multiply equation 1 by 2. So we're multiplying equation 1 by 2, and that'll give us 10c plus 10s is 500. Now notice how I've multiplied each and every single variable by 2 here. I've not just multiplied that variable by 2, I've had to do it to the whole equation. So 5c times 2 is 10c, 5s times 2 is 10s, and 250 times 2 is 500. So now we have a modified equation. We've got our, we'll call it 1b, which is the equation 1 divided times by 2. We have 10c plus 10s is 500. So 10 concession tickets plus 10 standard tickets comes to £500. And we've also got our second equation there, Kirsty's equation. We've got 8c plus 10s is 460. So now you will notice that we have matched the coefficients of s. So we've got 10s plus 10s. So the next part of this is we subtract the equations. We eliminate one of the variables. And in this case we're going to eliminate s. So if we subtract equation 2 from equation 1b here, we'll have 10c minus 8c, we'll have 10s minus 10s, and we'll have £500 minus £460. And that comes to 2c plus 0s is equal to £40. So now we have to solve for the remaining variable. Well, we have our equation, 2c plus 0s is £40. So our remaining variable is c, so we have to solve for c here. We can just get rid of this 0s, 0s is just eliminated. So we have 2c is equal to £40. Therefore, c is equal to £40 divided by 2, and c comes to £20. Aha! That should sound familiar. That's exactly what we had right at the beginning. So we know that this is correct and that this method works for at least one variable. So how do we get to solve the other variable? We've solved for c, we've got £20 for c, but now we need s. We're going to substitute that solved variable back into one of the original equations. So we're going to put c of £20 into one of the first two equations. So let's go with the first equation, 5c plus 5s is equal to £250. Let's substitute c, so c here, for £20. So 5c, so that's 5 times £20 plus 5s is £250. So 5 times £20 is £100 plus 5s is £250. Let's take this £100 over to the side. So we're subtracting £100 from both sides of this equality sign here. And what we get is 5s is 250 minus 100. 5s is equal to 150. And now we're going to divide 150 by 5. And s, standard ticket, comes to £30. And again, that's exactly what we had at the beginning. So we know that this method works. So to summarize, we have two unknown variables, and that requires at least two equations. that satisfies those, so we can solve those equations that satisfy for variables that satisfy the equation simultaneously. The easiest method is the elimination and substitution method. So we're going to match the coefficients of one variable. We're going to then subtract equations to eliminate that variable. We're going to solve for the other variable. We're going to then substitute that answer back into one of the original equations, and then we're going to solve for the remaining variable. So I would recommend that you rewind this video and go through this slowly if it's not clear for you. And the next step, you have to ask yourself, what other methods are there? Well, we've done the elimination substitution method, but what is the direct substitution method? And if we have three variables, so for example, we have a concession ticket, a standard ticket, and a VIP ticket, then how many equations do we need to figure out what each of these costs individually? And finally, what if the equations are not linear? In other words, they're polynomials.